Welcome to Walk About the Galaxy, the car talkish astronomy podcast, where the science is universal, the opinions are personal, and the vibe is ever so slightly tipsy.
Not today.
We are Strange Charm and Top the Astroquarks, also known as Josh Caldwell,
Addie Dove.
And Jim Cooney.
coming to you from the Walkabout Studios at the University of Central Florida. Be sure to stick around at the end of the episode for a group high five. Our stumpers are anti-symmetrical.
Ugh,
Weird.
That's upsetting.
That's right. Symmetry is beautiful.
Symmetry, but also asymmetry is kind of the only reason we're here in some sense.
True fact.
Spoiler alert.
Yeah.
Jim, left-handed or right-handed?
Oh. So I assume you're referring to some deep physics thing, but I'm going to answer it as if you were referring to which kind of people are the better people.
Oh.
It's left-handed.
Oh.
I myself am a lefty, therefore
Oh. So you look down on us.
I look down on you.
on us
righties.
Well, it's not that. It's like scorn.
You don't look down on us, you scorn us?
I
Great.
I feel so much better.
Yeah.
Yeah.
It's
Well,
jealous scorn, though.
It is. Because like
The world is
there's
made
about
for
10%
righties.
of the population is left-handed, so there's an anti-symmetry there and person-handedness, but there's also, of course, an asymmetry in how the universe works. But maybe you'll talk about that.
No.
Or not.
I was planning on you talking about it.
So there's like chirality, like a spiral, like how like molecules and
Molecules can
molecular
be
structure can
left-handed
be
or right-handed.
spiraled different ways. That's
Right.
left or right-handed.
Right, and the universe seems to be preferentially right-handed, and that's weird.
But that's sort of an arbitrary. Is it?
Well, it's
it's-
not. Anyway, it's not symmetric. Whether you call it right or left-handed is
Right,
irrelevant, but
right.
but it's not symmetric. Just like the world of people.
Yeah, and it's in particular, isn't it a big thing for molecules that are like life building block molecules,
so.
amino acids and things like that, or building blocks of amino
Typical
acids?
chirality, yeah.
They come with a left-handed version of a right or a right-handed version.
I
something
think
like
that's
that.
true, yeah.
Yeah.
We need a biologist on the program.
Okay. Well, we'll get a biologist on to
Tell
tell
us.
us more about left-handed or right-handed, but we'll have Addie tell us about matter or antimatter.
Could have said left shark or right shark.
I don't even. Oh, that was a thing
It
in
was
the
like
Super
two
Bowl,
Super Bowls
right?
ago or something, yeah.
Yeah. Okay.
What was mine?
Now I'm thinking about Baby Shark when I hear.
Oh,
shark.
that's true, yeah.
Yours was matter or antimatter?
I, like Jim, am going to be pretty, well, maybe not quite like Jim, but I'm going to go with matter
Okay.
because I enjoy being a
Existing?
being. Yes, and antimatter is not a great situation to be around.
For matter.
For matter.
isn't. Did
Yeah.
you see the? Shoot, what was the name of the original Star Trek episode where there's the matter antimatter? Oh my gosh!
That's
the
in one of the new movies, too.
Is it
The
really?
red matter, and then there's like antimatter or some. Red matter is like basically antimatter, but not.
I don't know what red matter is.
It was something
Antimatter
like
is-
the immunity syndrome, even though it's a very
Oh.
strange name for it because it
I don't remember
makes it
that.
sound like it has disease in it. But matter and antimatter famously annihilate each other, completely converting to energy, which I thought was just a totally made-up Star Trek thing when I was
when
a
you were a kid.
Yeah. Then I discovered antimatter is a real thing.
It is.
Right.
But
And
oddly, it's
an
not.
asymmetry between matter and antimatter is why the universe exists the way it does today.
Yeah.
Yes, at some point in the very early baby times of the solar system.
Baby
there
shark
was
times.
Baby shark times. Planck time, before Planck times.
I don't know.
During Planck times.
After-
Asymmetry occurred.
Yeah.
Yeah,
And the
after
world was
Planck,
born.
everything's after Planck.
Everything is
Nothing
after Planck
nothing
time.
before Planck time. But yeah, sometime in the early universe. But the asymmetry was extremely slight. Like for every
Yeah.
billion bits of
Go ahead.
matter, there's like 1,000,000,001 bits of the other way around.
Antimatter.
For every 1,000,000,000 bits of antimatter, there's 1,000,001 bits of regular matter, and almost all of that annihilated. And that's what a lot of the energy of the universe is today.
and
But
the-
that little bit that survived.
Is that
So that's
dark
how-
energy?
That's how we know that it's 1,000,000,000 to 1 is because of the ratio between energy and matter. Like, how do we know it was 1,000,000,000 and 1,000,000,001 instead of like 10 and 11?
Oh, right, yeah. I mean, it has something to do with the amount of matter in the universe compared to the amount of radiative
Photons.
energy. And yeah.
Okay. So because when those billion pieces of matter meet the billion pieces of antimatter, they become a billion photons or whatever, some
Ish.
number of photons,
You're right.
some amount of photon type light energy.
Right.
So that's how we know it's 1,000,000,000 to 1.
Right.
Yeah. Which is crazy.
Yeah.
It is crazy.
It's like just didn't quite cancel out. It's sort of like the universe wanted to just like only have light, like just light
You're
energy.
anthropomorphizing the
And they
universe.
just made a mistake in
tiny,
one
tiny
part in
mistake.
a
It was a
billion.
rounding error.
It's just a rounding. It's just off by 1 part in a billion.
Yep.
And yet that's
And
why
then
we're
Then
look
you
at the
end up with
mess.
stupid humans.
Look at the mess that it created. Just like, oh shoot, I forgot to do double
now there's
precision.
all this matter in my energy, or all this mass in my.
in my beautiful
my
light
beautiful
universe.
energy.
Yeah.
My beautiful energy universe is ruined by 1 part in a billion. And man. Today we're talking about potential new planetary missions announced by NASA, discovery of a near-Earth asteroid with a baby moon, what a gingerbread comet near the edge of the solar system may tell us about planet formation, fast radio bursts, much, much more. But first, this episode of Walkabout the Galaxy is brought to you by Light Travel Time. Are interplanetary distances keeping you away from that dream vacation to Titan? Is Mars too far for that weekend getaway? With Light Travel Time, get to Mars in just 20 minutes, or catch the majesty of Saturn's rings in just over an hour. With Light Travel Time, the solar system is your playground. As an added bonus, you'll have plenty of time to come up with a perfect response if your boss tracks you down while you're away. Light Travel Time gives you the luxury of hours of delay if the home office has a deadline. Sorry, folks, I'd love to help, but Light Travel Time. So leave those heavy suitcases and chemical propulsion engines behind. It's time to travel light with Light Travel Time. Strap yourself to the wings of an electromagnetic wave and leave your troubles behind with Light Travel Time, the only way to walk about the galaxy. Warning, light travel time may result in infinite mass bloating, infinite smooching in the direction of travel, and cessation of the subjective passage of time. Light travel time is not responsible for the violation of conservation of energy or loss or damage to personal property. Light Travel Time, the appliance of science.
Very
Oh.
nice. I would have tripped over that. That's very good. That was fast.
Not as fast as light.
Not as fast as light. Nothing is.
Yes.
That sounds fun. I could go for some light travel time. That's how they get around in Star Trek or Star Wars universe.
They're so,
They're so
crazy.
just jump around.
Yeah, just like everything in Star Wars and J.J. Abrams is just an hour away.
It's just an hour away.
Yeah. Just like,
But you can't blame J.J. Abrams for that. That's like the majority
I?
of science. You can, but
I
he's
want
not
like when you make
responsible.
a graph and you have two very different areas on the graph and you just put a little squiggly line in the middle that says I'm breaking my scale here and I have a new scale in the other part of
Yeah.
the graph.
Yeah.
Just put that in the movie. Just put a little
Yeah.
squiggly line.
yeah.
This
Something-
many hours has passed.
I don't know,
Just even
it's
put
like-
that on the bottom. 10 hours later or
I figure-
something.
Yeah, even in Star Wars, I figure if you're flying from one planet to like the opposite side of the galaxy, you should at least have some mechanism to take a pee break. It's like they're freaking flying around the galaxy in these X-wing fighters,
Yeah.
Where they can't even like stretch your legs or get a cup of coffee or anything. You're just like, da-da-da, that's it. And then you're just like,
You got to have ejection seats
So-
like in its expanse.
yeah.
Loaded in.
Anyway, the appliance of
Injection.
science is Zanussi. Have you ever heard of that?
Negative.
No.
It was an Italian appliance company purchased by Electrolux. Have you heard of Electrolux?
have heard of
It's a
Electrolux.
Swedish appliance company, which I didn't even know that.
It sounds Swedish.
But they
I
make
can see that.
dishwashers and things of that nature.
Appliances.
So, Earth news.
Earth news.
We're at 412 parts per million CO2 in the atmosphere.
Oh no.
Great.
That's not good Earth news.
It's
Yeah.
climbing,
It's not
climbing
great.
dramatically.
Yes.
That
That's
is really high.
highest
Weren't
level.
we just at like 402?
Yeah.
I feel like we were we just passed 400 like a year ago.
It's
2 years ago?
It's sort of weird if you're teaching physics or astronomy that you literally have to update your slides
Oh,
each
yeah.
semester
Right.
because the thing you're teaching has changed that much.
Right.
It's like common when you have a mission to another planet, like, oh, look at all these new things we found.
New pictures.
New pictures and
Yeah.
stuff like that. But yeah, it's not great when it's an Earth thing.
The fun thing about the CO2, not the fun thing, but the unfortunate thing about the CO2 thing, like the temperature record jumps around a bit. I mean, it's definitely obviously radically increasing, but in any given year, it could be a little cooler than the previous year and all that. But the CO2 thing just steadily marches up.
It's just
Yeah, and the problem is, right, there's a lag between the sources and like how the atmosphere responds. So like even
Yeah.
if we cut
If
off
we
everything
stop
right now, it would still
the
keep going
temperature
up for a
still-
while.
Yeah.
Yeah, a while's a long time.
Yeah.
It is. Yeah.
Well, the CO2
Decades.
Yeah, what is it in the atmosphere? It's
CO2
It's a
has
relatively
a residence time where if you stopped putting any more in the atmosphere, then you would have a decay over a time scale of centuries,
yeah.
Right.
small number of centuries.
Cool.
There is a seasonal fluctuation of CO2, but it just has to do with plant growth,
Mm-hmm.
and most of the plants are in the northern hemisphere. So when
Because
it's
most
spring,
of the landmass is in
Right.
the northern hemisphere.
right. So when it's springtime and summertime in the north, plants pull CO2 out of the atmosphere, so you get a little dip.
Yep.
And then in the winter, it all goes back in.
Right.
So there's a little.
It's a beautiful sawtooth, but then that overlay is just a steady, not a
Yes.
steady
It's
increase.
just like
a-
noise on your big signal, basically.
A
yeah.
dramatically increasing.
Right,
increase.
but at least it's like a smooth looking graph.
It
it's,
is.
It's not
It
like the
is.
temperature one that jumps around a lot.
Right.
It's this,
Yeah.
steady march towards
Inevitable.
bad news.
Yeah.
Cool.
Well, speaking of satellites, somebody mentioned satellites in there.
How do we get those measurements? Oh, those are ground-based measurements usually.
Yeah, as
So
a
that's like
Oh,
on a
you
K.
mentioned seeing pictures.
I
of-
usually mention satellites.
You mentioned like missions to new planets, and NASA this week announced
Yeah.
the first step in the selection of what's called a Discovery mission, the next Discovery mission.
Has nothing to do
where are we
with
going?
Star Trek Discovery.
It does not,
Much smaller budget, in fact.
probably.
There are 4 options. Yeah, so they announced their sort
So
of
this
phase
is winnowing
A
down
selection.
from how many to how many?
Probably like
20-something
20-something, yeah.
proposals.
Down to 4?
Down to 4.
All right, where are we
Yeah.
going?
And it's crazy because these proposals are huge proposals that take years to put together, and
Yeah.
the PIs are like on the edge of their seat. And then NASA waited like 5 extra minutes to put the announcement on their website. Oh, it was stressful. You scroll Twitter and everybody's like, why isn't it up there? Anyway, we are maybe going to Venus.
Ooh.
There are 2 missions selected to go to Venus. One for Io, the
Jupiter's
moon
volcanic
of
moon.
Jupiter,
Okay.
and one for. Can you guess?
Uranus.
I can't guess because I know it.
Triton,
Triton.
Yeah,
a
you
moon
didn't know?
of
I did not know that.
Neptune.
The cool moon
Literally.
in many ways. Yeah.
So it's icy. All of them have volcanic activity. Triton has cryovolcanism,
Yeah.
icy volcanoes. Io, supervolcanic, most volcanic body in the solar system.
Yeah,
Our
that's-
close-up view of Triton came in '89 from the Voyager flyby,
Mm-hmm.
and they saw these smoker geyser volcano type things.
Yeah.
And there was some discussion at the time. I don't know if this is still the leading theory of like a solid state greenhouse,
Oh.
where light goes through some ice at the surface,
Mm-hmm.
which then traps the radiative light from coming back out and heats up stuff that
subsurface.
drives the geyser activity there.
Hmm.
Tiny, super, super, super thin atmosphere. But Triton is a lot like Pluto.
Yeah.
Right.
Yeah, and there's a lot of comparisons, and I think I wonder if that's why it was like partly why it was
Maybe.
selected. It'd be interesting comparative
Yeah.
studies. But so Triton is a flyby, unfortunately. It
Right.
wouldn't be like an orbiter mission or anything, so you'd get a little bit of data. But they got a ton of data about Pluto from the New Horizons flyby.
Right.
Io, I think, is also a flyby, or maybe it's a Jupiter orbiter.
No, it's the Io Volcanic Observer or something like that.
So okay, observer means it's probably there longer. I don't remember. And then
We'll
2
have to
Venus
check that.
options, which also both got selected the last time they did these selections, but neither of them was then down selected to the actual selection.
So there's going to be just one of these survives in the
Maybe
end?
2.
One
So
or two.
or
last
two.
time they selected Psyche, the mission to the asteroid Psyche, and
Right.
Lucy, a mission to Trojan asteroids near Jupiter.
Right.
So there were no small bodies missions that were selected in these. It's dicey to pick an outer planets mission for the Discovery just because it's a pretty small budget. And so
What's the
it's
budget of
tricky.
these bad boys?
It's about $500 million,
Yeah.
which, as Addie says, is sort of like an Avengers movie. But so it's not a huge amount of money for many, many years of work in building a spacecraft and all the operations, things like that go on with it.
I guess Star Trek Discovery has an $8.5 million budget. So
Per season or something?
I think for the new season, yeah.
Or per
Oh no, each episode.
each episode. So it's about $100 million a season. Mm-hmm. Yeah. So we'll find out in a year or so. So each of these teams got $3 million to spend about a year really fully developing all the engineering and the management and stating all the risks and the backup plans and all that stuff that they would do.
That seems
And then-
frustrating. Because that seems like a lot of people are doing a lot
is
of
a
really,
crazy
really
amount
hard
of work.
work,
It's so much
and
work.
then it's not selected.
And it's
That's
like
right.
you don't really get a lot of money as the people working on it. There's not a lot of like budget for your salary. There's a
Yeah.
little bit, but these
Well,
are,
I mean, it's some employment level.
Yeah,
I mean,
yeah,
it
yeah.
depends on who you are in
Yeah.
the project, but
Yeah.
it's not like you get a prize.
No.
It's just your job continues.
Yeah.
You still get your
You can
paycheck.
keep trying to
and
do
this
the
is-
thing you want to do.
Right. And it's frequently a crazy amount of overtime work for people working on these missions.
Yeah.
I mean, Alan Stern, who's the PI of the New Horizons mission, which was sort of the next level up from these Discovery missions that flew by Pluto and flew by Arrokoth, the first of our mini science topics for today. The number of miles he logged flying back and forth between Colorado and the Applied Physics
What
Lab.
percentage of the distance to Pluto did he travel
Right,
in his
I know.
flights?
It's just a crazy amount of work. So people are doing this really because they're passionate about the discovery process
Right.
of seeing
No
these
pun
things
intended.
and getting the mission. Well, the pun was slightly
Oh,
intended.
pun intended.
The pun was slightly
Great.
intended there. Yeah. So we'll see in about a year. We'll be announcing.
Stay tuned.
Stay tuned to Walk About the Galaxy, and we'll tell you which of those missions, hopefully more than one, will be going on to what they call Phase B, the next phase of
exciting.
development to eventual launch. And the two that we talked about, that you just mentioned, Addie, Psyche, and Lucy, we've been talking about, and they're marching
Yeah.
towards launch. And so
Yeah,
we'll
they're
keep
both
you posted
launching in
about
a year-ish, I think. 2 years, maybe.
a couple of years, I think.
Couple of
yeah.
years. So.
One in 21 and the other in 22, I believe.
Yeah.
So it's all
21 is a
coming up.
year-ish.
That is a year.
Just saying.
I know. Yeah. So speaking of New Horizons, there is a paper published today, lead author Alan Stern, the PI of the mission, about what we learn about the formation of planets from the second thing that spacecraft flew by, which was this tiny thing we call a Kuiper Belt object. So,
KBO for short.
yes.
Yeah, so it was. So they had already flown by Pluto, and then they were like, "Oh wait, we can also, if we just do a slight trajectory adjustment, fly by MU-69 was its official designation, and they named it Arrokoth. A few months ago, a while back, and there was these really. It was a very quick flyby, so they really only got a few images of
Yeah.
the body. But they had done some ground-based observations beforehand, and they predicted what the shape of the body might be, and it actually matched pretty well.
Yeah.
But it seems flatter than we expected, right? So it seems like they were a little bit more smushed.
Yeah, they did this clever thing of sort of observing the shadow of the object on the stars. Sort of like, not really the shadow, but the stars behind are blocked by part of this object, which they couldn't see the object because the sun wasn't shining on that part of it, but they could tell the shape of it by the fact that the stars were disappearing behind it.
Right.
And so because they're, as you said, they were zipping by this thing with the sun behind you. So you just get one perspective view of it.
Right.
And you can't tell, are you looking at a snowman or like a picture of a snowman?
Right.
Right?
Right.
And it turns out that they're actually, we're looking at a picture of a snowman.
Right. It's very flattened. Yeah. It's bizarrely shaped. I when I first saw their drawings of what it kind of looked like, I refused to believe.
Yeah, and I think that they're
I
sort
still
of like,
kind of
there's
refuse
still
to
a little bit of a caveat on like how skinny it is.
Yeah.
And most of the modeling they've done, which is what one of the new papers is about, uses basically spherical bodies or more spherical bodies than like that really flat lobe shape.
So it sort of looks like a snowman, or it's
If you're
a
looking
big
face on,
It's
it
a big
looks-
round thing with a smaller round thing sort of gently stuck on top of it or on it.
Yeah.
And it turns out that the bigger one is fairly flattish. The
Yeah.
other one is
Probably
more
pretty round.
roundish.
Yeah.
And
Yeah, and you used a key word there. You said gently stuck on. So that's
Yes.
what. There's a couple of new papers. I think one looks at like the composition and the spectra that they got from it. But the other one is some really interesting modeling of like how slowly it would have been had to come together to form into the shape we see, which is super interesting to us because a lot of what we study is when you do these slow velocity collisions, how do you get things sticking together or building up? And obviously this is at a much different scale, right? They're like hundreds of kilometers. Tens of kilometers.
Yeah.
Ours are tens of millimeters,
right.
typically, or tens of microns.
different prefix.
Yeah. But they show that it must have been a very, very, very slow impact. So, like, they think on the order of meters per second kind of thing.
Yeah.
To actually have this stick together and form the way it did, which is not necessarily what you would predict from collisions in the early solar system.
Right. So this is being trumpeted, it's not really the word I want to use, but announced as confirmation of this pebble accretion model of the formation of building blocks of planets.
Heralded.
Heralded.
Ooh,
Excellent
great
word.
word. Great word.
Yes. As like, oh, we had two models of the formation of planets, and now we've proven it's Model B and not Model A or something like that, which, as is usually the case, oversimplifies things somewhat. But
Little
it does
asterisk.
show that there is this process where things come together gently and not violently. And of course, somehow we knew that had to happen because anytime these small things come together violently, they break apart.
Yeah.
Right.
So
And sometimes you have a net growth of the thing, but then a lot of loss, and so it's like
Yeah.
at some point you have to grow things bigger.
right.
So yeah, it's a pretty cool. Like the modeling, I don't know, the modeling for this stuff is always really awesome because they take a bunch of simulated stuff and throw it together and see what happens.
Very, very gently throw
Yeah.
it together. We have a special call-in guest
Ooh.
from previous top quark, Tracy Becker.
Prototype cork.
Prototype quark, Tracy Becker. But before we talk to Tracy about this discovery of a near-Earth asteroid which has a little moon.
Another paired object.
Yeah, exactly. Let me drop the trivia
Like it's
on
hot.
you.
I'm ready.
Yeah. The trivia has nothing to do with anything.
Great.
It has something
It
to
has
do with
something to do with
something.
whatever its topic is.
It has something to do with something.
Okay.
Yes. It is solar electric related. So maybe it has something to do with the Earth news about CO2.
Great.
It's multi-part.
What?
All
Crazy, right? I started...
Is
the
it
reason
multiple choice or?
there's multiple choice and multi-part.
Great.
Has to do with where is most of the solar electrical energy produced?
The sun.
Ooh, no.
Oh,
That's solar radiative energy.
that's true.
Solar electric energy.
Okay.
Gotcha. And first part's in the United States, second part's in the world. So,
Okay.
which state, as of when I got this data, this data was reported, which is the third quarter of 2019,
Okay.
which state in the U.S. had the second greatest solar electric capacity? And why second? Because California is the
I was
first.
to say, yeah. Okay.
So California is like way ahead in terms of total amount of electricity produced from sunlight in the U.S. Here are your choices: Arizona,
All 50 states.
Texas. No, I narrowed it down, but I couldn't bring myself to narrow it down to 5. So you have 6 choices:
Okay.
Arizona, Texas, North Carolina, Florida, New Jersey, or Nevada.
Okay.
All right. One of those is the number 2 in terms of total solar electric generation after California. The other parts of the question are going to be like which state has the greatest share of its electricity from solar. So kind of a normalization there.
Okay.
And then also which country produces the most solar electrical energy. I'll go ahead and give you your choices for that one.
Okay.
Okay. United States, Japan, Germany, China, India, or Australia.
Why do you always say the last one funny?
I don't know.
Okay.
He fancies
Maybe it's
himself.
because those are the answers.
Maybe. Maybe I'm trying to triple reverse double psych you out.
Every time.
Yeah.
Okay.
Before we talked to Tracy, though, I forgot to mention some nerd news.
Oh.
Oop.
Out of order nerd news, unacceptable.
Well,
We have a format, Josh.
I know. I'm
Continue,
violating.
continue.
I'm doing some symmetry
Violating
violation.
the space-time continuum.
It's about, since there's all these different formats for getting shows and movies and things like that, it used to be easy to keep track of science fiction shows and
Oh, yeah.
movies and things, and now you have to like do
Work
some
at
effort.
it.
So I was just looking into it. Have some other science fiction shows out there that you or some of our listeners may not be aware of, might be interested in.
Okay.
There are a couple of time travel shows on Netflix.
Okay.
One is
Currently?
called
I mean,
Well-
they're on
Coming up?
Netflix.
you can stream them now.
Now, okay.
Yes. They are available now.
I mean, wait till you're done listening to the podcast.
Please finish listening to the podcast.
Yeah, yeah.
One of them is called Dark. Have either of you heard of that?
Never even heard of
I've
it.
heard of Bright. that
Dark. I haven't heard of Bright.
was a different
That was
movie
a
on
Netflix
Netflix.
movie, right?
Yeah.
Was it?
Was it
With Will Smith?
Will Smith, yeah.
Oh,
It was also sci-fi. It
Okay.
was interesting. It was not as bad as I expected.
okay. Dark is a German language production,
I think I tried to watch that one time.
and it's time travel-y.
I think I tried to watch that one time.
And the other, which I haven't seen, but it's on my list. And the other one is French, and it's just 4 episodes. And it's in French. The title is Il était une seconde fois, which is translated as Twice Upon a Time.
I was like, it is the second time?
Yeah,
Twice Upon a Time?
Twice Upon a Time.
Oh.
Yeah, and it's a weird. They're both sort of weird, offbeat time travel
Is it the
stuff.
sequel to Once Upon a Time?
No,
Oh.
and I love time.
They're
I love
subtitled?
me some time travel stuff.
Oh yeah.
So
Is that why you like Interstellar so much?
Twice Upon a Time is got some pretty weird
Good time travel?
time travel stuff going on. It involves a cube, which I wanted to turn into our trivia, but it was too complicated. So,
Cubes?
Yeah,
Pretty
Cubes are real
complicated.
simple.
yeah. Cubes are simple. Let us welcome our guest on the phone.
Yay.
Former Top Quark Tracy Becker, who is now research scientist and group lead at the Southwest Research Institute. She's doing a million things. She's working on the Europa Clipper mission. But as a graduate student and even as an undergraduate, she worked at the Arecibo Observatory, and she's now working with the project that you're a deputy PI on, Addie, the CLASS
Center
project
for Lunar and Asteroid Surface Science.
as a sort of Arecibo liaison in
Mhm.
some
And
sense.
and a little bit with FSI and
Right,
Yeah.
the Florida Space Institute. And so she is coming to us over the phone to tell us about this observation of a binary asteroid that's had a close call with the Earth. So Tracy, tell us about this new discovery from Arecibo.
So the asteroid 2020 BX12 had been detected only about a week before the Arecibo observations were made. Does
that mean it was first discovered just a week before this was made?
That's right. It was first discovered, which is why it has the name 2020 in it. So usually when you see years, it has to do with when it was first discovered. It was discovered by a optical telescope survey in Mauna Kea in Hawaii. We're the first ones to detect it, to detect the asteroid. And then with Arecibo radar, they pinged it because it was a near Earth asteroid, so it was close enough to the Earth, not too close, but close enough that we could actually use radar to send a signal out to the asteroid, see that reflected signal back. And when you do that, radar is a super powerful tool for discovering a secondary or a moon and finding these binary systems. So prior to those radar observations, we had no idea that it also had a moon orbiting it.
So this is like it's using light echoes, but it's the same general idea of what a bat does to find a mosquito. It sends out a wave and sees or hears the echo back from something. And in this case, there were 2 echoes coming back, basically.
Yeah, that's exactly right. So it's sort of like sonar in that exact sense, and you can actually get images of the asteroid and the moon as a result. And the way you really see that it's a moon, not only do you get the 2 signals back, but you observe it over time, and so you can actually see the movement of that secondary as it orbits the primary asteroid.
Right. So that's kind of like a difference in time between the 2 echoes coming back. If they're at the same distance from the Earth, you'd get the echo back at the same time, and then as that moon is orbiting the asteroid, that split in those echo signals would grow and shrink as the moon is orbiting.
Yeah, so you'll see that echo coming from a slightly farther away distance, just based on how long it took that signal to get back to Earth. And so you can kind of create in one dimension, you can kind of create that range or that distance plot.
That would be the
image.
So what's really making this possible is the light travel time between the radio telescope and the asteroid. Coincidentally, light travel time is actually the sponsor of today's episode. So it's good for them, good timing for them.
Wow.
Yeah.
Wait, can I add one more part to it?
Sure.
So so one element is seeing that time, and sorry to the sponsors, but there's another aspect to it as well, which is the Doppler shift due to the rotation of the objects. And so the secondary is probably spinning. It spins much more slowly than the primary. So the main asteroid is spinning every couple. I had the number somewhere, but it's a fairly fast spinner, something like a couple of hours. And the secondary, the moon, is probably tidally locked with the primary. So just like our moon and our Earth, we always see one side of the moon. That's the same case for this asteroid, and so it's orbiting over some, I think it was 60 hours, and so that's its spin as well. And so the Doppler shift actually comes up in those images as well, and so you can see how fast the light is being warped by that spin as well, and therefore you can you'll see two signals that look very different because the primary and the secondary are spinning at different rates.
Okay, cool. I guess I didn't realize that those little tiny asteroids could get tidally locked in the same way that the big moons like our moon and the moons of Jupiter and Saturn do as well. But how big are these things? How big is this asteroid and its moon?
So the moon is about 230 feet wide, and the main asteroid is about 540 feet wide at a minimum. So we can't say exactly how big they are, but we can kind of give a minimum size based on that reflection that we saw.
Can you put that in real units of meters or?
I did originally, but now I'm just looking at the article that
We actually decided that the official unit of length for Walkabout the Galaxy is 5K.
Okay, that's appropriate for the team. I understand.
Yeah. So it's a tiny fraction of a 5K across.
Yeah, it's here. I can have the real numbers right here in a sec.
We could run around this asteroid in just a few minutes.
Yeah, so the main object is 165 meters.
In diameter?
Yes.
Okay. Yeah.
Yep.
So these are tiny. So that's about the size of maybe a football stadium or something like that
Right.
for the main thing. And then the moon is how big did you say?
It's probably at least about half the size.
So earlier you mentioned that it was close enough, but not too close. Why is any close too close? I mean, obviously you don't want it to hit your telescope because then it's hitting the Earth. That would be bad. But what else is too close?
No, that's it. I mean, too close just means it's not going to hit the Earth. I wanted to make sure everyone knew it was not on any kind of. It is considered a potentially hazardous asteroid because of the distance that it comes and its size. But one of the beautiful things about radar that I just find so amazing is that when you ping something with radar, just like a police officer's radar gun can be used to track your velocity, and it also can do your position. And so when we do radar observations of asteroids, we know extremely precisely how far away, how fast it is, and we can really correct its orbit. So we know going into the future, up to the next 100 years or so, where that asteroid is going to be. And so we can really eliminate it as an actual threat to the Earth, and just say that it is still considered a potentially hazardous or near Earth asteroid.
But not for the next 100 years. It's not going to hit us at least.
Correct.
Yeah.
Again.
So, but for Arecibo, and you've been to Arecibo, you've done some observations there and some work there, and you're working with them now.
I don't know if you can see it, but I've got my Arecibo mug, but it's
Nice.
feeding because my tea isn't so hot anymore.
And that telescope famously is this giant radio dish antenna that's like in a valley in Puerto Rico,
Yep.
pointing up. So do you have to have the asteroid just coincidentally, luckily, fly straight overhead? How did they discovered this a week before? What was it like to get ready so they could figure out they could make the measurements of this thing?
Yeah, so fortunately, so it is as you described, a giant dish, but what they do have is what they call the Gregorian dome, which hangs on top of it. So if you have seen some of those famous movies like GoldenEye,
Yeah.
and you see Pierce Brosnan hanging, that is actually the platform that is hanging above the dish, and so that has some ability to move along a track, and so that gives us some steering capability. So you don't need the asteroid to be coincidentally just directly overhead. That said, there are limitations to where we can point the telescope. So there is only a certain region in the sky that the asteroid has to come through in order to see it.
Right. Cool. Thanks very much.
Thanks, Tracy.
Thank you.
Always fun to hear from Tracy Becker. And now let's move out to the more astrophysical realm
Ooh.
from the planetary realm. So, Jim, we've talked about fast radio bursts before,
We have.
and they kind of irritate me.
Because they're
Really?
because they're so fast, or because they're so bursty,
Yeah.
or because they're so radio-y.
and confusing.
Oh, can we call them Furbies?
But they're exciting because we don't know what
No.
they are, right?
That's why-
Mysteries are always very exciting.
Okay.
Yeah. Just like
If
all
they're
these
done
crazy
well.
things in the rings that we don't understand.
Like Knives Out. That
Like
kind of
Knives
mystery
Out,
is well
it's
done.
done well. Yes.
Well, FRBs, I think, are done well. They're very because these are a fast radio burst, as the name suggests, is a burst of radio energy that we receive here at Earth from some very distant thing. They're all of the sources of these are extragalactic, so
But what's the
outside.
I have a
fast?
question.
What's the fast part?
The vast part is they're milliseconds in duration.
So how is that? So why are they both fast and burst? Why are both of those things in the name?
Exactly. It's
Is
just
that
a
redundant?
short radio burst. It's not really fast.
Okay.
Or it's a
Okay.
fast radio
It's traveling
pulse
at the speed
or
of light,
something.
just like all.
Okay.
Like all radio.
All radio.
I think there's some. I think what Addie and I are
The
saying
Department of Redundancy.
here. Yes.
The
it's
fast and the burst. Okay. All right. If that annoys you, I can accept that.
The Department of Redundancy department.
Yeah.
But these fast radio bursts have been a mystery for a long time because they're huge amounts of energy, but we only see them very briefly. And for a long time, they were just there's one there in the sky, there's one there, and that was they didn't
Here a
repeat.
burst, there a burst.
Yeah,
Everywhere a burst.
and we didn't know what they are, what they're coming from, what is going to produce this huge amount of energy in a very short period of time and then be gone.
Is it antimatter?
No.
Oh, okay.
Is it left-handed people?
Left-handed people die an average of something like 6 years earlier than right-handed people.
Really?
Something
I don't
that
believe
large.
that. No,
That is, no,
I
true
don't
fact.
believe.
Left-handed males die on an average of 6 years before
Oh.
right-handed males. That's at least a number that I heard.
Is that because
very
you have other
recently.
deficiencies?
That's a number that you heard.
That's a number that I heard recently.
Did you read it on the internet?
Somebody tweet it.
Well, all right, listeners, check that.
We'll
I
look
think
it
it's
up.
true. It has something to do with accidents and things like that.
You're more likely to
it's
stab
not-
yourself
it's
'cause
not
you're
like
using the
we
scissors
die
wrong?
of heart attacks and stuff more often. We die of accidents and things because the world is built for right-handed people subtly.
I can believe that there is a much greater incidence of rare types of accidental deaths
Yeah.
based on that reasoning, but I'd be alarmed and very curious and surprised and mystified to discover that was enough of a difference to like dramatically lower the life
I
expectancy.
agree.
Maybe
And-
it's a small number statistics
I agree.
thing.
Well, and don't get me wrong. Having just said that, it now sounds dumb to me as well. It sounds like it should be like months or something difference or a year, but like
Yeah.
6 years sounds a lot. Anyway, that's off topic. Fast radio bursts.
It's not off topic because
There's
we
a New
talked
York
about,
Times article from 1991 about this.
Okay.
Being left-handed may be dangerous to life, study says. Be careful,
I'm scared.
Jim.
I could die today.
Be
I don't know.
careful.
NASA warns.
NASA warns.
Okay. Anyway,
Okay. Fast radio burst.
Fast radio
So what are they? So in recent years, we've had some.
10 years.
That's what I'm saying. It's he doesn't believe it.
Sorry,
Josh
fast
is
radio
shaking his
bursts.
head. Fast radio bursts.
Bursts.
In recent years, we found a few that repeat, and that's kind of cool because if they repeat, that is, we've seen them from the same source in the sky, then we can learn a little bit more about
and
them.
are they repeating periodically?
Well, up until now, no, and that's what this article that we're just reading today is all about. Is the first one that they have found some periodicity to the source.
So just to be clear, if these things, as you said before, and for our listeners, you were pointing at me, and then you're pointing at Addie, and
Oh,
then
yeah.
you're pointing at Diego. There's a radio burst over there, and then that's it. But then we saw that like if we looked at that same spot,
Right.
occasionally it would flash again, but with
Right.
no rhyme or reason. Now you're saying like every 6 months.
Now we're
there's a
saying we
burst or
found
whatever.
one with the again sexy, very very sexy name FRB180916.J0158 plus 65.
Oh yeah.
Yeah. That guy has been, we've seen a number of bursts from them, and it seems that there is a rough periodicity. It's not like
It's not like a pulsar.
it's not like a
period.
pulsar, which has an extremely regular thing. It's a somewhat regular thing. That is, there's these little 4-day windows where it seems to burst a few times in those 4 days windows, and that happens every 16 days.
Huh.
And
So what is it? What is it?
This is the question. But this is helping us understand what it might be. So
But
this
what could
thing,
it be? What could it be?
Well, so early on, we thought maybe these things were collisional, like a neutron star crashing into another neutron star or something like that created these bursts. But clearly, if they're repeating, that can't be the case. It certainly could be the case for some FRBs, some fast radio bursts, but not for these
Collisions,
repeating ones.
not like the collisions that make the gingerbread man in the outer solar system with two ice balls bumping into each other super slowly.
Yeah,
You're
this is a
talking
little
about
bit more
two
energetic collision.
Crazy dense stellar remnants,
Right.
neutron stars smashing into each other space-time rending collisions.
That's right. That's right.
Oh, that sounds
it's
like a great
creating
sci-fi movie.
Huge amounts of energy over very short periods of time. So that could be the case for some fast radio bursts, but it's clearly not for these repeating ones because that
once-
happens once and then it's done.
And then you're done.
So these repeating ones, or this repeating one, must be something. I mean, usually when we see repeating things, it's something like the pulsar that has something to do with rotation or spin. Right? It's something
Right.
either rotating or spinning around. We can't think of any really great.
Well, there are some binary star systems where you've got one star sort of bleeding material onto the other,
Right.
and then that bleeding of material can maybe produce. It builds up to some critical level, and then
nova.
something happens,
Right.
and then you have to bleed some more material on. That happens at a certain rate. Could it be something like that?
It could be something like that, but it would have to be, it's dramatically more energetic than that. That's called a nova, right? In astronomy, that's something dramatically more energetic than that, but
A
it
nova
could be something
is,
like that.
And a nova is like a big thing, but it's not like a supernova.
Right.
And
That's why
right.
supernovas are bigger.
Right.
Right, and these things are dramatically
novas.
more energetic
Mega.
than supernovas. So this is
Are they meganovas?
They're more powerful. Are they more energetic? Is it more total energy, or is it
that
just
I don't know the answer
yeah,
to. It's certainly
okay.
more powerful. That is, more energy per
per unit time? Interesting.
and
They need a
so-
better name. Fast radio burst sounds really.
Yeah, that's the kind of observational name. So we
Yeah.
see it as a fast radio burst. But if we
It
could
could
figure
be-
out what they are, we'll give it a sexier name.
Yeah, I mean there are things that like we've discovered one way and then we see it and we've seen it other ways and they had two different names for a while and
That's
then
right.
you sort
It's
of
like, oh, it's the
realize
same
it's like
thing.
AGNs and pulsars, right?
Yeah.
Are often
So eventually we'll figure out what some or all of these things are, and that's going to be awesome. But for now, they're a mystery.
Okay.
Just wanted to come back to the left-hander thing. That's not true.
Oh, what's not true?
The study was done on a very small subset of people, and it was looking at only people who had been dead. And the statistics are weird because they were looking at older populations, and like people didn't report as left-handed for a long time. And anyway, it's probably not true.
Okay,
All right. So
so I'm safe.
good. You're safe.
Well, I don't know.
You'll be
don't
around
run
for a
around with a
while.
knife that you're not supposed to be holding or something.
Right. Do still look both ways before you cross the street.
Yes.
Whatever, dude. I'm living full out now.
Yeah, when you're in
I
the
don't have to worry
States,
about it.
drive on the right. When you're other places, just be careful.
Okay.
But
Oh,
yeah. So before we've got a closing thing about information that I thought was interesting that Jim will tell us about. But before we get to that, let's talk about our trivia.
All right.
Okay.
I'm ready.
Which state after California of the United States leads the pack in terms of total solar electric capacity? Is it Arizona, Texas, North Carolina, Florida, the home of the Astroquarks, New Jersey, or Nevada?
That's Florida's new state motto.
Home of the Astroquarks.
Home of the Astroquarks. Nevada.
I was thinking about. I'm going to go with Texas.
It is North Carolina.
Whoa.
Can you believe it? In
I
fact,
can't. That's why I
significantly
didn't guess
more
it.
than any of those others, which are all about the same
Why?
in terms. Why is North Carolina? They just put some
Solar
incentives in and put in a bunch of utility scale solar panels. California has 26 gigawatts of capacity. North Carolina, number 2, 5.6. So just to give you a scale.
Wow.
Florida, we're at 3.4.
Oh, not too far behind.
Gigawatts of capacity. Which state gets the largest share of its electricity from solar? So obviously California has a lot of solar, but it has a lot of people and a lot of power consumption. So your choices are California, Texas, Vermont, New Jersey, Nevada, or Arizona.
Nevada. I'm going to stay on message.
I'm going with my friend Nevada.
You are both correct.
Yes.
Edging out.
Oh.
Actually, I'm sorry. It is California.
What? You screwed us.
I totally.
You got us all excited that
I
we
got
had
you all
it, right?
excited.
Oh man.
I got you all excited. It is California, but Nevada is number 2.
Okay.
Well,
So excluding California again,
yeah,
it is Nevada.
California's 19.5% of its electricity comes
Go
from
on with
solar.
your bad self, California.
Nevada 13%.
Not bad.
Edging out Vermont.
Yeah, I noticed Vermont was on the list.
Yeah. Vermont gets 11, almost 12% of its electricity from
There's,
solar.
I mean, that's probably
Whereas,
a
like-
much like it's a lower requirement.
Yeah, but next door, New Hampshire is like less than 1%. It's weird.
Different
All right, now
policies.
for our international listeners, which country has the greatest solar electric capacity?
Our domestic listeners can listen to this question too.
Yes. United States, Japan, Germany, China, India or Australia?
Germany.
China.
It is China.
Yeah.
United States is number 2. Germany number 4, which is it's the Vermont of
Yeah, Germany is
because
its
it's
area
north
is tiny compared
and it's
to.
not.
Well, Germany has
huge.
some policies in place to like go entirely renewable by
they've-
25 or something crazy.
Yeah.
I don't know. Maybe it's not quite that
They're
soon,
being
but
very
it's
aggressive,
very aggressive,
with
yeah.
getting away from fossil fuels. So yeah, China has about 1/3 of the global total solar electric
That makes
capacity.
sense.
Random final part of this trivia:
Okay.
which country has the largest of its total electrical usage coming from solar? Like California's got, as a state, has 19.5% coming from solar. Which country has that as the highest percentage?
Germany.
I didn't give you the choices, and you'll never
annoying.
guess it. So the answer
Is
is
it the Netherlands?
Palau.
Honduras.
Oh,
Yeah.
correct. Would not have guessed.
Of the countries listed, Germany is number 2.
Good job.
I'm going to call myself correct then.
Yes, which is 7.9% as of 2018, which is pretty good. Good
Pretty
for
good.
them. All right, tell us about information.
Oh, just a quick random thing. Yeah, we often on the program talk about dark matter and potential candidates. It's frustrating because we don't know what dark matter is, and we haven't found it in 60 years of looking for it. And so people are always coming up with new dark matter things. We talked about on a recent program crazy 6-quark combination, sexaquarks.
Sexaquark.
But another idea that was recently forwarded, which I don't think is a great idea, but I think is a fascinating one, was this idea that information may have mass associated with it.
I know there was this whole
That
thing
way-
about black holes and whether or not information is one of the things that is
yeah.
like lost when it goes into a black hole or not.
Yeah, well, because there are other ways of kind of formulating fundamental laws of nature. You could think about information as being a fundamental thing rather than matter and energy being fundamental things. And so that's what the laws of thermodynamics are largely based on information, or at least the second law of thermodynamics is based on information. And it could be that that's the fundamental thing in the universe. And this one author suggested that perhaps more information means more mass, and if you do some calculations, some rough calculations, you could get that to make up the missing matter in the universe. Now, I think we know a lot more about dark matter than this guy is giving us credit for. That is the distribution of it and so forth. It wouldn't match what he's suggesting. But I think that's a fascinating thing because I've always found the second law of thermodynamics, which basically says.
Well, Josh Caldwell's version of the second law of thermodynamics is everything is terrible and is just getting worse.
Shit. I don't think you need the first part, but the second part, yeah.
Everything is just getting
Everything
worse.
is getting worse. Yeah, I mean, that everything tends towards disarray and entropy increases. This is a law of physics, but it's a law based on information. I always thought it was the coolest law because I always thought, what if all these laws of physics that we have that are based on matter and motion, what if those aren't the fundamental things? What if it's something totally different? I'm having a hard time vocalizing what I mean by this.
Wording
but,
that?
Yeah.
So information would be, for example, I mean, just the normal ways we think of information, but like something is organized in a particular. Well, how would you?
Yeah,
How
I mean,
would you- what do you
this
mean
guy
by
actually
the word-
suggests a way to test this by taking like a disk drive that is empty,
Okay.
measuring the mass of it ridiculously precisely, and then filling it with information and measuring that again.
What kind of scale do you need for that?
Right. No, I mean, he's suggesting these. I mean, he
That is awesome.
that would be awesome. It's next to impossible because the amount of the mass difference would be tiny, and measuring the mass of things to that degree is. So he's talking about an experiment the scale of like LIGO or something like that.
Right.
In order
Yeah.
to do this, we're not going to do that just yet, but it is at least something interesting to think about, and it's nice that he's at least thinking along the lines of here's how you would test this, right? Because that's how science should work.
Right. So while everything gets worse universally, locally things can get better. So
Sure.
on the Earth, things can be getting better because we're maybe sucking in. The sun's entropy is going up and our entropy is going down. So we're generating information here on the Earth. So this theory would say like that the mass of the Earth has increased in the last 1,000 years.
because of
the
insulin.
Gutenberg,
Not just because we eat more.
right?
Something
what
along these lines. I don't know. I mean, this is a brand new thing, but
That's cool.
It's at least interesting to ponder.
That's cool. Happy Valentine's Day, Astroquarks.
Yeah, we're recording this on Valentine's Day. Actually, we're getting it in trouble because it's like 5:30 already on a
Yes, on
Valentine's
Valentine's Day.
afternoon. Our
If you
significant
don't
others are
celebrate
mad.
Valentine's Day, then it doesn't matter.
Doesn't matter. Doesn't matter.
Well, it may have felt like the time for Light to travel round trip to Mars. It was actually just about that much time.
About that, right?
So when you go to Mars and send a happy Valentine message home, you can listen to an episode of Walkabout while you wait for the reply.
Awesome.
If you like this episode of Walkabout the Galaxy, get a job as a barista and write it out one letter at a time in the foam of your customers' hot beverages.
Yes.
Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy, where you can see Jim and Addie wonder what the hell I'm talking about now. Catch up on old episodes wherever you get your podcasts. Thanks to our listeners in Portugal and around the world. Follow us on Twitter.
At walk_the_galaxy.
And ask us questions anywhere using hashtag WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Our production assistant,
Our prediction associate.
our production assistant and production assistant and video guru, a man of many hats, is Diego Rodriguez. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the Astroquarks signing off until the next episode of Walkabout the Galaxy.
That's terrible. Sex cork.